Hi everyone. In my today's topic, I want to teach you how to design full wave rectifier circuit. And here is a diagram for full wave rectifier circuit with the input supply of 24 volt 50 Hz AC. After rectification, we do get the waveform like this. But practically, how will be the waveform for DC? This is it. We need to get waveform like this. This type of DC waveform is called as pulsating DC. We generally don't entertain this type of waveform. So to convert this type of waveform to this type, we do generally add a capacitor in parallel to it. So do you think after adding capacitor, you will get exactly like this? No, practically impossible. How do we get the waveform? We generally like this. So generally, after adding capacitor in parallel to the circuit, we do generally get waveform like this, which is almost like a DC. So most of the engineers, what we do is we generally assume ripple voltage to be very less. So what is this ripple voltage? I'll explain you now. So ripple voltage is nothing but this particular peak voltage, and this lowest point of voltage. This difference between these 2 points is generally called as ripple voltage. Usually they are indicated as delta VR. Delta is nothing but difference between peak value and least value. So for calculation of capacitor, we do generally assume ripple voltage to be very less, maybe in terms of millivolts. Yeah, of course, it's better to use in terms of millivolts. So let me explain how to choose the value of capacitor. Come on. For choosing the value of capacitor, we have equation I into 2F delta VR. And this is the equation for choosing capacitor. I is nothing but load current, F is nothing but supply frequency, which is 50 Hz, and the delta VR, as I said, it is the ripple voltage. So assuming my load current is 1 amps, just an assumption for just a calculation, just to teach you how to choose the value of capacitor. And as I said, ripple voltage should be very least. So let me consider ripple voltage to be around 50 millivolt, which is nothing but 0.5 volt. Okay. Now let's calculate it. Capacitor 1 divided by 2 into 50 millivolt or 0.5. We end up getting 20,000 microfarad. But practically 20,000 microfarad capacitor is not available. So what should we do? We need to consider the value which is available near to it. The value which is available near to it is 22,000 microfarad. Now let me explain how to calculate the voltage rating of the capacitor. Before calculating the voltage rating of a capacitor, first and foremost thing is we need to find the peak voltage after rectification. How to find the peak voltage after rectification? So let me explain. This is actually 24 volts AC supply. To convert this per 24 volt will be RMS value. To convert to peak value, we need to multiply by root 2. Okay. Peak value after rectification will be 24 into root 2 to convert peak value. From RMS to peak value, we need to multiply by root 2. And during positive half cycle, these two diodes will conduct. During negative half cycle, these two diodes will conduct. So we need to consider diode drops for individual half cycle. So for what will be for diode forward drop voltage of single diode 0.7. Since we are considering two diodes, we need to multiply by 2 into 0.7. After this, we will end up getting around 32.54 volt. So this is the peak value of rectification. This is a peak value after rectification. We will generally get here 32.5 volt. Here we get 32.5 volt. Okay. To select the voltage rating of the capacitor. The capacitor voltage rating should be more than this. So practically 35 volt capacitor is available. Hence we are using 22,000 microfarad capacitor with 35 volt peak value. 35 volt is more than this. 35 volt is more than this. So for safety purpose, this is the rated value. Hence we got the capacitance value as 22,000 microfarad, 35 volt. This is the capacitor value. So till now I have explained how to find the value of capacitor with the voltage rating. Now comes the picture of output voltage. So what would be the output voltage? So this is it. Output voltage will be varying from this point to this point. Output voltage will be varying from this point to this point. And you may say this variation is quite negligible, since the voltage variation is around, the ripple voltage consider around is just 0.5 volt. So some of them won't entertain even this. So what would be the least voltage here? So since I assume this is 32.5, the peak value, and this least voltage, to calculate this least voltage, we need to subtract by ripple factor. 32.54 minus 0.5, which will be around 32.04 voltage. So the voltage will be varying from 32.5 to 32. This variation is very least. So some of them won't entertain this type of variation. In such a case, to maintain the stability of output voltage, it's better to add Zener diode in parallel to it. So what will be the function of Zener diode? It's just to maintain the stability of the output voltage. So let me add a Zener diode like this. When we add the Zener diode parallel to it, we'll get the average of these two values. What will be the average of these two? We will end up getting around 32.23 volt like this, and this will be the output voltage after adding Zener diode. Before adding Zener diode, output voltage will be varying like this. Since we have added the Zener diode, output voltage is maintained stability. Output voltage is stabilized. So how to choose the rating of Zener diode? So output voltage rating is 32 volt. So let me consider the Zener diode which has a rating of 35 volt, which is more than this. If I choose less than this, Zener diode will burn out. So has some capacitor. So 35 volt Zener diode is better to choose here. So 35 volt Zener diode is IN 4751, and this is the rating of Zener diode which I am going to choose here. So output voltage will be getting like this. Hope you understood with this video. If you like this video, please do share and subscribe for my channel. Thank you.